Boilers require substantial capital investment, operating budget, and cost to operate. I'm Ed, and we'll take a quick tour of a number of ideas which might be of help to improve your boiler operations. A typical boiler plant is about 28% efficient, and combined with the efficiency of the steam system at about 42%, total steam losses can be about 70%. We'll review a number of possible options to improve overall efficiency. Most steam systems are a loop, with fuel being burned at a central point to convert water to steam, which in turn contains large amounts of thermal energy. Pressure transmits the energy to process equipment, HVAC equipment, and other applications requiring heat. Hot condensate is recycled back to the boiler plant and fed back into the boiler. Take a moment and look around your current location and recognize that most everything you see required thermal energy in the form of heat and temperature to make those products you see. Thermal energy comes in many forms, and the energy data in the table lists the quantity required to provide 1 million BTUs. Four common forms of energy are used to fire a boiler. Using natural gas as a base cost at $5 per million BTUs, you'd have to purchase the other forms at the values shown. As an example, for an electric boiler, power cost would have to be 1.7 cents per kilowatt hour. If electric power costs are currently 10 cents per kilowatt hour, then operating an electric boiler would cost right at 5.9 times the cost of a gas-fired boiler. This chart provides data based on natural gas costs in the range of $5 to $12 per million BTUs. The efficiency of the boiler is taken into account in these calculations, with electric boilers in an example operating in the 98 to 99% range since they have no stack losses. Having the ability to operate a boiler with multiple energy sources will allow you to fuel shop for the least expensive source. For all boilers burning of fuel, stack losses are the most significant, with an average of 21%. The combustion curves show the optimum point is to regulate oxygen at 3% by regulating the combustion air to the burner. A combustion analyzer is the tool used to optimize combustion, and boilers should be tuned up on a regular basis. We would suggest 4 times per year to coincide with seasonal changes. Another opportunity to improve efficiency is to match the boiler size to the connected load. All boilers radiate heat loss, and the amount of heat lost is a function of the physical size of the boiler. Comparing the connected load to the boiler as compared to its maximum capacity will provide you with data. Using the formula, you can calculate the radiation loss for your boiler plant. To measure fuel-to-steam efficiency, consider adding flow meters to measure your boiler plant operations and track the data on at least a monthly basis. In this example, the cost to produce 3,450 pounds per hour of steam is compared for 3 different size boilers. One boiler horsepower will produce 34.5 pounds per hour of steam, so 100 horsepower is required. Since boilers operate best at about 80% continuous load, the best selection would be a 135 horsepower boiler. Lead lag control systems allow you to match boiler capacity to your load requirements. We don't sell boilers, but we can provide a very broad range of products used in a boiler plant, covering the range of piping products, pumps, and all kinds of control devices. We can also source hard to find and replacements for obsolete parts in many cases. Thanks for watching, and we hope it can be of help.